right, so we left off with integrals of symmetric functions as we were talking about the chain rule and so on. So let's kind of not do the chain rule for these, but talk about even and odd functions, which I think we've done before, right? So if you have an even function, the most basic even function is y equals x squared. I want you to think about, when it says even, think about y equals x squared. So if you have something like y equals x squared, and you're integrating from negative a to a, how could I simplify the integral? Does it equal 0? Does it just go away? Does it? Yeah, it becomes twice, right? So it's going to be 2 times the integral from 0 to a of f of x dx. And that will be useful to us sometimes, especially with polynomials, because we like when we have 0 as one of our limits of integration for polynomials, right? So we like to be able to plug in 0 for the second part of it. If f is odd, that would be like y equals x cubed. And if we go from negative a to a for that one, yeah, that's when it's equal to 0. Exactly. So every even function is said to be symmetric around the y-axis, and every odd function is symmetric about the origin. And so I believe I've shown you that before. Like if you have x cubed, and you rotate it 180 degrees like that, does that make sense? You get exactly the same graph. So if you rotate around, that's what it means to be symmetric across the origin. It means that you flip it over 180 degrees. Okay, or you rotate it, I guess I should say. It's like flipping twice, flipping for x and y. All right, so if you see something like this and it says x to the fourth minus 3x squared plus 2, and you see that you're going from negative 3 to 3, okay, you want to decide, can I make this problem easier or not? So can you make it easier on yourself? Yeah, this is an even function. One quick way to check if something is an even function is, can you plug in like the same number? I would say 2. Like if I plug in 2 here and negative 2, do you get the same thing in that function? Yeah, because 2 to the fourth is the same as negative 2 to the fourth, and so on. Okay, or even look at the degrees. See how we have 4, 2, and this is 2x to the 0? Those are all even powers. Make sense? So if they're all even powers, it has to be an even function. So all of this is even. So the easiest way of doing it would be to go from 0 to 3 and double. So we're going to have 0 to 3, and then we have our x to the fourth minus 3x squared plus 2 dx. So as we integrate, we do our x to the fifth with a 1/5 out front. We have minus x cubed plus 2x going from 0 to 3, and we're going to take that result and we'll double it. So as we start simplifying, we're like, okay, I got 3 to the fifth. Do you guys know 3 to the fifth? Bigger. That's 3 to the fourth. So 243 over 5 minus 3 cubed, 27, plus 6. So we have that, and then the whole second part of that becomes 0. Do you see why that's nice for us? We like when the whole second part becomes 0. So I would probably combine these and get negative 21, and then get our common denominator. So we're going to have 243 over 5 minus, if I get common denominators, it's 105 over 5. I know you guys love fractions. It's your favorite thing in the whole world. 138 over 5. Do you guys know 2 times 138? 276 over 5, and that's our answer. All without a calculator. Amazing. Not really. I'm not really good at mental math. I'm okay. But if you do enough math without a calculator, you just have to not pull that phone or calculator out all the time and try it. All right, so how about this next one? So x cubed minus x. Do you guys see how this x is really x to the first? So all of those powers are odd, right? And think about it. If you plug in 2, you get 8 minus 2, right, which is 6. If you plug in negative 2, you get negative 6. That's what an odd function is.
We have a lot of these problems.
Yeah, because this becomes just 0, done. Because we knew that it was odd, and it went from negative 5 to 5. So what if you have things like, you don't have to write these, but negative 4 to 3 x squared plus 3x to the fourth. Is there a shortcut for that?
No.
No, because it's negative 4 to 3. So you have to do the long way, right? You have to do everything. Okay, what if you had something, this is what the AP test likes to do. They like to do like sine of x cubed minus 3x to the fifth from negative 2 to 2. What do you think? It's equal to 0, right? Because it's an odd function. So you have to recognize that, sine is an odd function, and x to the fifth is an odd function, and so on. So the AP test likes to kind of sneak those in as well. Do you guys remember sine and cosine? So sine is the one that looks like this, right? I don't know. Can you rotate it around? Turn your whole book around. Oh, man, so sad. All right, rotate. It's supposed to be the same, but I'm off. I don't know what happened there. It's my axis didn't rotate too. I'd have to like group them all together. It won't let me do it. All right, anyway, so if I rotate it around, I do get exactly the same. So you can take your book and you can move it around. You get the same. This is an odd function. And think about like 30 degrees is the same, is the opposite of negative 30 degrees, right? So sine is odd. Cosine is the one that's even. See how it's symmetric around the y-axis? Tangent? It is. It's an odd over an even. And if you look at the graph, it's odd. Right. So if you have something like a function that looks like 3x to the fifth minus x over 2x to the fourth minus 3x squared. This ends up being odd. Because when you have an odd divided by an even, or an even divided by odd, the odd wins. It's going to be odd. You can test them, but yeah, it works out that way. Yeah. No. You wish. All right, so yeah, if you're plugging in like 2 and negative 2, can you think through it that way? Yeah, if you plug in 2 and negative 2, clearly it's going to be the opposite because the top was the opposite. Okay? All right, so let's do this more practice with U-substitutions. So the big thing to remember about U-substitutions is it's not going to be for every single problem. Some of the problems do not involve U-substitutions. So I feel like once people learn it, they just want to use it all the time, and it's not. We don't use it all the time, right? Sometimes we have our regular power rule. The good thing about U-substitutions is on calculus AB, this is the only other integration rule that we need. So we do the power rule. Do you know what I mean by the power rule? So if I'm integrating x to the 7th, it's 1/8 x to the 8th, right? That's the power rule. And we have U-substitutions, okay? But when we did derivatives, we had the power rule. So like the derivative of x to the 7th would be 7x to the 6th. We had the product rule, quotient rule, chain rule, right? So we're only doing 2 of these. There are other integration methods, but you learn those in Calc 2 or BC Calc. Okay, so number 1, I don't have to do U-substitutions. Should I do U-substitutions on this one? Yeah, I probably would, because it's raised to the 4th, right? So if it's raised to the 4th, you would have to FOIL that out 4 times, right, in order to simplify, right? We don't want to do that. So if it was squared, I would probably just multiply it out and then do the antiderivative. But since it's to the 4th, yeah, I would let my u be x squared minus 16, and then my du is going to be 2x dx. Okay, and again, I'm looking for things that I'm replacing. So this is u to the 4th, and then our 2x dx is right here. It's going to be replaced with du. And our goal is to replace every single thing in our integration with the integration from x's into u's, right? Are we doing that? Yeah, we have u to the 4th du. Everything has u. So then we integrate. So we're like, okay, that's 1/5 u to the 5th plus c. And then after we integrate, we're then able to switch back. So we're like, well, we didn't have u's in the original problem, but we had x's. So I do 1/5 x squared minus 16 to the 5th plus c. And that's it. So on number 2, do we feel pretty good about number 2? U would be what? And then what's du? Negative 6x dx, which actually does the full replace, right? This is du, and this is u cubed, or not u cubed, u to the 1/3, cube root. So as I replace, I'm like, okay, I have u to the 1/3 du. So if I integrate, I add 1 to the power, so I have u to the 4/3 with a 3/4 out front, plus c. So 3/4, 1 minus 3x squared, to the 4/3 plus c. Okay, and that's U substitution. Okay. But sometimes we have to do a little bit of manipulating of the du part. So sometimes we have to like divide the 2 over or whatever. Okay, and that's a situation like this next one. Yeah, so go ahead and write your u and your du. Yeah,
Okay,
Leia.
so for like when you have to divide or
Mhm.
whatever 2 or something. So yesterday at math club, one of the teachers told me you had to add. So on one side it's like 1/2. You have to add the -2 on the other side. Then they cancel each other out. So I'm very confused.
There's 2 ways to teach U substitution. I am only teaching it one way,
Okay.
but I can show you what that is.
No, it's okay. I'd rather
Okay.
just. put it in one
I
way.
found this is the easier way for my students to.
Okay, I just want to.
Yeah. Uh-huh.
What just happens to the 2x dx? Is it just like
It was absorbed into the du. Like that 2x dx, this whole thing here was replaced with du. Because those are equivalent. Du is equal to 2x dx. Huh? What happened to the du? The du is part of the integration sign. It like sandwiches it. So we have this and this like that. And in between we have our u to the 4th. Right? Just our normal integration that we had. Couple more. So t to the 5th plus, or t to the 4th plus 5. So you should get a du of 4t cubed dt. But all we have here, Phil, is the t cubed dt that we're trying to replace. This part's going to be replaced with u under square root. Right? Do you see it? So this part's gone. We're saying what's left that I need to replace? T cubed dt needs to be changed into something with u's. So we're almost there. We have 4t cubed dt. So if we have 4t cubed dt, we want to divide that 4 over. So I'm going to do 1/4 du is going to replace t cubed dt.
Okay, so like if it replaced like on number 2, since the du was -6x, you don't have to do.
Right, you don't have to divide because that -6 was already there. You can if you want to, but then you'd pull that -6 out front and it would cancel. So I have 1/4 the integral of the square root of u du. Okay, so we integrate. So we're going to have the 2/3 u to the 3/2, but we still have that 1/4. So getting there? So 2 over 12 becomes 1/6 u to the 3/2 plus c. And our u was t to the 4th plus 5. Okay. Okay, I'm doing some examples because I think people are confused. All right, think about what your u would be and write your du. So write u equals du equals. So when we wrote our u, we had 1 plus r to the 4th. Its derivative, so the derivative of 1 plus r to the 4th is 4r cubed. So we have our dr. All right, so we don't want that 4 because the 4 wasn't in. If there was a 4r cubed, you would leave it there. But I would just go ahead and divide by 4. So I have 1/4 du is going to replace r cubed dr. So this integral becomes 1/4. My r cubed dr is replaced by that 1/4 du, and it's 1 over u squared, like that.
Can you also do u to the -2?
Yeah, and I actually, when I do it, I write u to the -2, so then it's already set up for the integration. So it's u to the -1 with a 1 over -1 times 1/4 plus c. Okay, so writing this, you can write it lots of different ways. You can write -1/4 and then our u, which was 1 plus r to the 4th, raise the -1 plus c. Or you could write it as -1 over 4, and that part, the 1 plus r to the 4th, is on the bottom, right, plus c. And you could even distribute that 4 if you want to. There's lots of ways that you could write it. Okay. So how about you guys try number 5? All right, so as I'm walking around, it looks like you guys are getting it. So you should have u equals 1 plus x to the fourth. du is 4x cubed and dx. So we look at our problem and we're like, well, that bottom is the square root of 1 plus x to the fourth. That's the square root of u. But I still have this x cubed in dx. And so the x cubed dx is actually part of the du term. It's here. So we're going to pull the 1/4 to the other side. So 1/4 du equals x cubed dx. And we're going to replace the x cubed dx with 1/4 du. Okay, and you can put the du on the numerator. Like I think I saw Alexa put it on the numerator. That's fine. Or you could do like 1 over the square root of u. That's fine. Okay. But you should get to the point where you're integrating u to the negative 1/2. So you have u to the 1/2, right, when you add 1, and a 2 with that 1/4. So you're going to have 1/2 u to the 1/2. So 1/2 u, which was 1 plus x to the fourth, to the 1/2 plus c. Is it a negative? I don't know. I don't think it is. Because you would add 1 to the power, right? So negative 1/2 plus 1. Yeah, I gotcha. All right, so number 6, what do we think? Yeah, we don't need a u substitution on number 6. So that's what I was saying. Like, don't get like so caught up with u substitutions that you're like, oh, u is equal to 4x squared or something. Like, it's not. This is just one that's a normal power rule. So it's rewriting it so that's 1/3 x cubed plus 1/4 x to the what power? Negative 2. So then we integrate it, right? So we do 1/3. I'm going to have my x to the fourth with a 1/4, right? I'm going to have my 1/4. I'm going to add 1 to the power. 1 over negative 1 is just negative 1. Multiply those, plus c. So your final answer should be 1/12 x to the fourth minus 1/4 times x to the negative 1, or you can put the x down here with a 4 plus c.
Isn't that the same situation as if you had like x cubed times like 2 plus x or something?
Yeah.
You just like multiply it out.
Yeah, you remember when we did derivatives? So she's saying something like this. Maybe I have like a 4x to the fifth. Like I gave you things like that with derivatives to try to trip you up. So you'd think, oh, I have to do the product rule and the quotient rule. No, we just did 2x cubed plus x to the fourth, and then we divided each of those by 4x to the fifth and wrote it as 1/2 x to the negative 2 plus 1/4 x to the negative 1, and then took the derivative, right?
Yeah.
We're doing the same thing with integration. A lot of times things are going to simplify like that. The things that are going to be hard for us with integration are when we have things like x plus 2 on the bottom, where it's like more than one term on the bottom. Okay, that's when we're probably going to use u substitutions, right? So let's try the next ones. So we have this one. Do we need a u substitution?
You can multiply it out.
Yeah, so what we're going to do is this 2 pi is a number. I'm just going to pull that out. And then the x is going to be multiplied into each thing. So I'm going to integrate 9x minus x to the 5 over 2 when I multiply that x in. So I'm going to have my 2 pi out front. And when I integrate 9x, can you guys kind of do that in your head? You'd have the 9 times the 1/2. So it's 9 over 2 x squared. How about the x to the 5 over 2? 2/7 x to the 7 over 2. Are you guys getting better at those? Okay. All right, and then I'd probably just multiply the 2 pi in. I mean, you can leave it like that too, but the 2 pi out front, I mean, that's a number, so I distribute it. So we're going to get 9 pi x squared. Well, I canceled the 2, yeah. So 9 pi x squared minus 4 pi over 7 x to the 7 over 2 plus c. So that's how I'd write my final answer. Okay. All right, what do we think for number 8? What should our u be?
Tan x.
Yeah, tangent x. I'm going to leave that one for you guys to do together. So let's kind of move around here. Let's go down to 11 and 12. I'm going to do 12 first because 11 is a lot harder. Whoops. So let's do number 12. So if I let my u equal 1 plus 2x squared, my du ends up being 4x dx. So as I start looking, I'm like, well, I definitely have the square root of u. And my x dx is in here. And I need to replace that. So it's going to be replaced with 1/4 du. So I'm going to have 1/4 and du. But remember when we learned these yesterday, or whenever I saw you 2 days ago, these are definite integrals. They have numbers on them. And we know that definite integrals, like if I have f of x going from 1 to 5, right, those are 1 to 5. Those are x values, right? So we're integrating with respect to x previously. We're using x values. But now we're integrating with respect to u. That's what we say when we say du, integrating with respect to u. So we want everything to be in terms of u. Okay, so if x is 2, what is u? So we go back to this equation right here. So plug in 2 for x, what do we get? 9, right? And what about u being 0? Or not u being 0, x being 0. So we get 1, right, for u. So instead, we're going from 1 to 9. Okay, and we keep them as u's throughout the rest of the problem. That's the easiest way to do these, instead of switching back to x and plugging back in. We talked about that yesterday, 2 days ago. All right, so I'm going to have 1/4 the integral of 1 to 9 u to the negative 1/2 du. So I get 1/4 times 2 u to the 1/2 going from 1 to 9, which is 1/2, and I'm going to go ahead and leave that 1/2 out. And I'm going to plug in 9, so this 1/2 just kind of went here. And I'm going to plug in 9 to the 1/2 minus 1 to the 1/2. Do we know 9 to the 1/2 minus 1 to the 1/2? Yeah, it's 3 minus 1, right, which is 2. So I have 1/2 of 2, which is 1. Ding, ding, ding. Right. Okay, so what makes 11 harder? Did you guys kind of look at it and you're like, why is Mrs. Cox saying it's harder? Yeah, then we have the u is equal to 2x minus 1, so du involves just the 2 dx. So as we start replacing, you're starting out and you're like, oh, I'm good. I have 1/2 du is replacing the dx. All right, we got this 1/2. I got my du. I got my over the square root of u. And then you're like, wait a second. I have an x here. Okay, and that's the part that's bad. We don't want an x there. We want everything to be changed into u. Okay, so this is what we call the change of variables method. So sometimes we have to change our x's into u's after we do the u substitution. So right here we have u equals 2x minus 1. So we're going to add 1 over, and we're going to divide by 2. So u is going to be u plus 1 over 2, or sorry, x is going to be, jeez. X is going to be u plus 1 over 2, or you could write 1/2 u plus 1/2 if you want. So I didn't leave you much space for this. If you have to flip to your additional notes, you can always flip to your additional notes. All right, so as we start replacing, we're like, okay, I got my u plus 1 over 2, and I'm dividing by the square root of u. And I have a 1/2 out front. This is why I always say AP Calc, like, it's not just AP Calc that you're learning. Like, you guys can be really good at the calculus skills, but if you're really terrible at algebra skills, it doesn't matter how good you are at memorizing your calculus facts, right? We have to know algebra skills too. So we have to know how to simplify this. Okay, so before we do that, how about our numbers, our limits of integration? Yeah, so our 1 now becomes 1 still, and our 5 is now 9. So it goes from 1 to 9. All right. So let's see. So let's simplify this. Okay, think about if you have u plus 1 over 2 divided by the square root of u. Do you guys know that that would be u plus 1 over 2 times 1 over the square root of u? Like that. We're going to use that. We're going from 1 to 9, right? So we're going to have 1/2 the integral of u plus 1 over 2 times u to the 1/2. So I'm going to write u to the 1/2, and I'm going to make this 2 out front, 4. You with me still? The 2's from the bottom, so it multiplied It was from the bottom of this one, not the other one. That's what you're saying. So it was here. So it's like u plus 1 over 2 divided by the square root of u, which becomes times 1 over the square root of u. So this 2 and the 1/2 are on the same level. So these go together. You get it? All right, so we end up having 1/4, the integral of 1 to 9. I'm going to have my u divided by u to the 1/2, which is u to the 1/2 plus u to the negative 1/2 du. Lovely, huh?
Favorite.
This is where math textbooks always say, the proof is left to the reader, and they just say equals and they give a number. So they're like, you can finish the steps at home. Wouldn't that be nice? I'll do it for you. So 2/3 u to the 3 over 2. I'm going to have a 1/2 there, so I'm going to have a 2 out front. Going from 1 to 9, and I'm going to multiply that whole result by 4, 1/4. 9 to the 3 over 2, do you guys know it? 27, so I have 27 times 2/3. So 27 and 3 reduce out. 9 times 2, 18. 2 times the square root of 9 is 6, right? Minus the 1s. The 1s are easy, 2/3 plus 2. All of that multiplied by 1/4. So fun. So 24 minus 2, so I'll do 22, minus 2/3. What's 24 minus 2/3? Yeah. 22 minus 2/3. 66.
So that'd be
Minus 2.
64
64 thirds
thirds.
times 1/4. 64 thirds.
You could just simplify
So it equals
64,
16 over 3. Ding, ding, ding. Whew, that took a long time. Brutal. So that's why I said, let's do that second one first. All right, so I'm going to have you guys try 13 and 14. So think about whether you need a U-substitution or not. And I want you to try 9 and 10 together. Okay, one last thing I do want to mention. So sometimes you get, and this might be on your homework, so write this in the additional notes because I got a couple examples actually that I'm going to show you. Sometimes you need a U-substitution for part of the problem, but not all of the problem. So do you guys see how you have x plus cosine of x here? I mean, we know that we're integrating x first, right? 1/2 x squared, and we're integrating cosine of x, right? That's not a U-substitution problem. Do you guys see that? So a lot of times when we're integrating, we're kind of doing like both. We're breaking it apart. Sometimes you have to do that when you're doing U-substitution. So if I had something instead that looked like x plus sine of x cubed times cosine of x, you can't say, oh, I'm just going to keep this all together and u is going to be sine of x, right? That would be really complicated for the second part of that equation, the second part of the expression, the x part. Do you see what I'm saying? So what I would do is I would just integrate the x by itself, and then I would do the u substitution for the second part of it. So I'd say, oh, my u is going to be sine of x, etc. Right? Does that make sense? So you can break things apart. Don't think that you have to look at it all as one big chunk. And then the other thing that's in your homework that I haven't talked about is, what if we do have that f is even? So if I tell you f is an even function, and maybe I tell you that the integral from 0 to 5 of f of x is equal to 6, and I ask you -5 to 5 of f of x, what would you write? You would write 12. You might see things like that as well. What if f was odd? Then the integral from -5 to 5 would be 0, right? So you might have questions like that pop up on your homework as well, where you don't have an actual function, but it tells you f is even or f is odd. So think about those as well. All right.